Hello students, I hope you all are doing fine. Today we are going to start the new topic, that is solubility. So solubility of a substance is its maximum amount of solute that can be dissolved in a specified amount of solvent under specified conditions. Now this solubility is dependent on some factors, that is, it depends on the nature of solute, that is, what kind of solute you are taking, nature of solvent, what kind of solvent you are taking, the temperature and the pressure. Now let's talk about solubility of a solid in a liquid, that is, how a solid is soluble in liquid. Now solids are soluble in liquids only when their intermolecular interactions are similar. Okay. Now the solubility of a solid in a liquid at any temperature, it is defined as the maximum amount of solute in gram which can be dissolved in 100 gram of the liquid to form saturated solution at that particular temperature. Okay. So before moving into the topic, let's first discuss some related terms which are related to solubility of solid in liquid. The first term is dissolution. Okay, the first term we have is dissolution. All right, so let's talk about dissolution. Now dissolution, as you can see here, dissolution is when a solid solute is added to the solvent. Okay, some solute particles dissolves and the concentration increases in the solution. This is known as dissolution. We will talk about it later, about the process of dissolution later. Then crystallization. Crystallization is when some solute particles in solution, it combine together, okay, with each other, and they get separated out of the solution. This process is known as crystallization. After that, dynamic equilibrium. Dynamic equilibrium is that condition where the number of solute particles going into the solution is equal to the number of particles separating out. That is, both the dissolution and crystallization process occurs at the same rate. This is known as dynamic equilibrium. Okay. After, the next term is saturated solution. Saturated solution is the solution in which no solute can be dissolved further at a given temperature. It is known as saturated solution. All right. Okay. Now the next term that we have to discuss here is unsaturated solution. Unsaturated solution is the solution in which more solute can be dissolved without raising the temperature, means there is a space for adding more solute. All right, this is known as the unsaturated solution. After that, supersaturated solution. So solution which contains more solute than that would be necessary to saturate it at a given temperature, it is known as supersaturated solution. All right. Okay, so before moving into the process of solubility of solid in liquid, let's talk about the process of dissolution first. Okay, that is how the process of dissolution takes place. Let me take a page here. Okay. So dissolution, what is dissolution? Dissolution is the formation of solution. Okay, it is the formation of solution, and the opposite of dissolution is crystallization. Okay, the opposite of dissolution is crystallization. That is, crystallization is where the solute particles settle down. Okay, solute particles settle down. All right, so let's discuss the process of dissolution. Now we know that a solution is made up of both solute and solvent. Okay, solution is made up of both solute and solvent. Now the formation of solution is related to the intermolecular forces of attraction that exist between the solute and the solvent particles. Now during the formation of solution, the rearrangement of particles occur. That is, a solute will dissolve in a solvent only if the intermolecular interactions or you can say the intermolecular forces within the solute and those within the solvent, they become similar to those occurring between the solute and solvent molecules. All right. The intermolecular interactions or forces within the solute and those within the solvent are similar. Okay. So when the solute is dissolved, say salt, just say salt and sugar. When you are dissolving, when the solute is dissolved, say salt and sugar, when you dissolve salt and sugar and you stir it around, you will see that the particles becomes smaller and smaller, isn't it? The particle becomes smaller and smaller and ultimately gets disappeared. So what happens here? So students, let's have an atomic vision kind of, and let's imagine that how these grains, they fall apart and they dissolve. Okay, so the solubility, it depends whether the substance is an ionic and covalent compound. For example, if we are taking salt, NaCl, table salt, all right, here we have Na plus and Cl minus ions. All right. On the other hand, if we take sugar C2H4O8, it is a covalent compound. All right. So here we have carbon, then we have hydrogen and oxygen. Okay. So what happens here? Salt is an ionic compound. Okay. Here we have sodium ion, Na plus, which is a metal, and Cl minus, which is a non-metal. Sugar is a covalent compound as it is made up of non-metals. Okay. So when you dissolve salt in water, the atoms that make up the salt, that is Na plus and Cl minus, they dissociate. All right, they dissociate, and you can and what happens is they break apart, and they are all going to float around in the water individually, like this, Na plus, Cl minus, like this. All right. And but when you dissolve sugar in water, the sugar molecules, they break apart. Okay, but not the individual carbon, hydrogen and oxygen atom, but the whole sugar molecule. The atoms and molecules in sugar, they stay together. Okay, so this is how ionic and covalent compound dissolves. All right. Now salts are dissolved in water. They are dissolved in water because there is an attraction between the ions and the ionic lattice and water molecules. So here basically ion dipole interaction comes into play. Okay, when an ion and a nearby polar molecule, all right, that is water here we can say, they attract each other, an ion dipole force results. So when NaCl, it dissolves in water, it gets dissociated into Na plus and Cl minus ion. All right, Na plus, when it dissolves in water, it dissociates into Na plus and Cl minus ion. The ions become separated because the attraction between the ions and oppositely charged poles of the H2O molecule overcome the attraction between the ion themselves. So the Na plus interacts with the negative part of the water molecule, that is Na plus, sodium ion, it interacts with the negative part of the water molecule, that is OH minus, and the chloride ion, it interacts with the positive part of the water molecule, that is H plus. All right, so this is how it interacts. So let me show you that how does it interacts. Let me draw a lattice structure. So this is Na plus, just a minute. Na plus and Cl minus, they are all bound together like this. here we have Cl minus, Na plus, here we have Cl minus, again here we have Na plus. So in a crystal lattice, basically so many ions, they are joined together. Okay, so like this it is. So if we have water molecules here, so as I said that the negative part of the water OH minus will interact with the positive part of Na plus, okay, like this. Similarly, the positive part of the H2O, that is H plus, it interacts with Cl minus. Alright, so this is how it interacts. Fine. Okay, now okay, so now let's talk about the process of solubility of a solid in a liquid. So the complete process for the solubility of a solid in liquid is given here. Okay, so in the first step, what happens when a solid solute is added continuously in a solvent? The solute keeps on dissolving and the concentration of solution increases. Okay, so then what happens that some solute particles in a solution, it gets separated out of the solution. This process is known as crystallization. So after some time, what happens that at this some solute particles in a solution get separated out of the solution. So when after that a stage is reached when the dissolution and crystallization process, they occur at the same rate. Okay, and at this stage what happens, the number of solute particles going into the solution will be equal to the solute particles which are separating out, and then we can say that a stage of dynamic equilibrium is achieved. At equilibrium, what happens, no more solute can be dissolved, hence a saturated solution is obtained at a given condition of temperature and pressure. Thus the concentration of solute in such a solution is its solubility. Okay, fine. So after that we have to talk about the factors which are affecting the solubility of a solid in liquid. What are the factors which affects? So as discussed earlier also, as I said earlier also, that solubility, it depends on the nature of solute and solvent, and then it depends on the temperature. Okay, and it also has effect on pressure. Fine. So the factors which affects the solubility of a solid in liquid, and first we have to discuss the nature of solute and solvent. So the nature of solute and solvent, so this can be understood by saying that like dissolves like. It means that the polar solvent or polar or ionic compounds like NaCl, it gets dissolved in polar solvents only, that is water. Okay, and it will almost be insoluble in non-polar solvents like benzene. Similarly, non-polar, that is covalent or organic compounds like naphthalene we have, okay, anthracene, they are soluble in non-polar solvents like benzene, ether, and they are less soluble in polar solvents like water. Okay, so the solubility in general is a result of three kinds of interparticle interaction, that is solute-solute, solute-solute, then we have solvent-solvent, solvent, solvent, and solute and solvent and solute, or solute solvent. Three types of interactions. The solubility in general, it is a result of three kinds of interparticle interaction, that is solute solute, solute solvent, or solvent solvent interactions. Okay, now the next factor that we have to talk about is the effect of temperature on solubility. So let's understand this with the help of a simple activity. Okay, let's take 3 beakers. Let's take here 3 beakers. All right, and fill all the beakers with 100 centimeter cube of water. We are filling this 100 centimeter cube of water in all the 3 beakers. Okay, now let's take the initial temperature to be 25 degree centigrade in all the beakers. It will be 25 degree Celsius. Alright, now add 3 different type of solute in all the 3 beakers. Let's add first NH4Cl in the first beaker, NH4Cl in the first beaker, NaOH in the second beaker, NaOH in the second beaker, and in the third beaker let's add NaCl. 3 different types of solutes are being added here. Okay, now again when you will check this temperature using a thermometer, you will see that in the first solution the temperature is decreased to the temperature, that is the final temperature T2, it has been decreased to 22 degrees centigrade or Celsius. In NaOH, the solution having NaOH, the temperature has decreased to increased to 35 degree Celsius, and in NaCl there is no significant change in temperature. Alright, the temperature remains same. So what does it imply? Think about it. What is exactly happening here? So in the first type of solution where we added NH4Cl, okay, heat is being absorbed from the surroundings. Alright, so it is known as endothermic process. Whenever heat is being absorbed, it is known as endothermic process. So here which type of reaction is taking place? Endothermic reaction. In the second type of solution, heat is being released here. Okay, heat is being released here. So it is what? It is exothermic. Whenever heat is released, it is exothermic change. So here the process which is going on is exothermic reaction, and here in the third process there is no significant change, so it is known as isothermic. Okay, isothermic, there is no change, the temperature is same. Now what happens when temperature is increased? Okay, in all the endothermic processes, while making the solution, you will see that the solubility increases with increase in temperature. Alright, the solubility increases with increase in temperature. So what is the reason behind this? So as I just discussed earlier, that there is a when you dissolve solute in a solvent, you have solute forces and solvent forces. Alright, so when solvent forces they dominate, the solution is formed. Okay, alright, so whenever in this type in first type of reaction in endothermic processes, when the solute force is strong, heat is being absorbed from the surroundings. Okay, so if the heat given off in the dissolving reaction is less than the heat which is required to break apart the solid, the net dissolving reaction is endothermic. Okay, now the addition of when you will apply or add heat here, alright, when you increase the temperature, what happens? The addition of more heat, it facilitates the dissolving reaction by providing energy to break bonds in the solid. So this is why increase in temperature increases the solubility. Okay, so this is what happens here. After that, so we can say that endothermic processes is directly proportional to temperature. Okay, if you increase the temperature, the solubility increases. Alright, and solubility also increases. So now if you increase the temperature in exothermic process, what happens? When you increase the temperature in exothermic process, solubility decreases. So we can say that the solubility in exothermic process is inversely proportional to temperature. So now why does it happen? Alright, so let's what happens is the heat which is given off during the dissolving process is greater than the heat required to break apart the solid. Then the net dissolving reaction becomes exothermic. Okay, the heat which is given off during the dissolving process, if it is greater than the heat which is required to break apart the solid, the net dissolving reaction becomes exothermic. So the addition of more heat, it inhibits the dissolving reaction, since excess heat is already being produced by the reaction. Okay, so now you can also understand this using in accordance with the Le-Chatelier's principle. Le-Chatelier's principle. Okay, so Le-Chatelier's principle, it states that whenever a stress, for example heat, pressure, concentration of one reactant is applied to an equilibrium, the system will adjust if possible to minimize the effect of the stress. Okay, now consider the case where the solubility process was endothermic, that is the heat was added or being absorbed from the surroundings. An increase in temperature puts a stress on the equilibrium condition, alright, and causes it to shift towards the right. Alright, the stress is relieved because of the dissolving process, it consumes some of the heat. Therefore, solubility increases with increase in temperature. Now, if the process was exothermic, that is heat was given off, a temperature rise will decrease the solubility by shifting the equilibrium towards the left. Okay, this is what it happens. So okay students, so up to now we studied about the solubility, that what is solubility, okay, and on what factors solubility depends, that is it depends on the nature of solute, nature of solvent, temperature, pressure. Okay, and we also talked about we started the solubility of a solid in liquid, that is how a solid dissolves in liquid. Okay, so we also seen the terms related to solubility of a solid in liquid, then the process of solubility of a solid in liquid, then the factors affecting the solubility of a solid in liquid. So students, I explained earlier that the solubility of solid in liquid, it depends on the nature, okay, nature of solute and solvent, then temperature and pressure. These two we have discussed. Okay, but in the pressure I haven't have much, because pressure doesn't have any significant effect on solubility of solids in liquids. Why? Because solids and liquids, they are already they are highly compressible and they practically remain unaffected by the pressure change. Okay, so liquids and solids, they are already compressed, that is why pressure does not have any significant effect on the solubility of solids and liquid. But pressure does have a very significant effect in the solubility of a gas and liquid, that we will study in the next video. Okay, so for now that's all for today. Thank you so much and have a great day.